Today, the challenge is to produce more clean energy in a sustainable way. To meet this challenge, solar farms are springing up all over the world. These farms produce electricity or green hydrogen, but only when the sun is shining and high in the sky. That also means they are lying dormant around half the time.
Together with the European Space Agency and our partners, we ask ourselves this question: how can we best exploit the huge financial and material investments being made into these farms? It is now possible to deliver clean energy from space through the concept of direct sun reflection.
With oriented mirrors in space, natural sunshine can be accurately reflected back to Earth. In low orbit, a constellation of more than 200 mirrors, each 1 kilometer in diameter, simultaneously powering a solar farm would provide as much energy as peak daylight at noon. Extending the constellation to 4,000 mirrors would allow for providing almost 2 hours of additional bright sunshine on around 30 farms at dawn and dusk every cloud-free day of the year throughout the seasons. Solar farms could receive up to 60% more energy over the year without any additional cost to their infrastructure. They would just have to pay for the extra light. As soon as a satellite is close to the horizon, it moves on to the next one on its trajectory.
DSR will generate 40 times more energy than that required for its deployment and operation during over 30 years. This is a best-in-class optimization compared to other energy production methods.
The DSR would be able to produce green electricity and hydrogen at very competitive prices compared to other methods. Every euro spent on the DSR system will generate 3 times its worth in energy. As a result, over 8,500 megatons CO2 will be saved over 30 years, and 800 square kilometers of solar farms are avoided thanks to better use of the existing. This infrastructure is also interesting because it is modular and progressive, as well as be designed according to space sustainability principles.
The technology needed for this is rapidly maturing, and within 2 years of the start of the project, it will be possible to launch a first small-scale mirror into orbit to demonstrate the feasibility of the concept. By 2043, DSR will be fully operational.
At the end of the 1960s, it was Arthur D. Little who launched global thinking on the production of energy from space, thanks to the pioneering and very innovative work from our former colleague, Peter Glaser.
What some people call science fiction is actually the reality in your lives.
Every day, space helps us observe the Earth and understand its climate, and helps billions of people find their way around, communicate, and live better lives. The challenge for space is now to provide the world with more clean energy for a sustainable future.